right, so 4.5b. Tell me what the last thing that you, oh, and I fixed my YouTube, well, I didn't, Jacob Miller fixed my YouTube channel for me. So thank you, Jacob Miller, shout out to him. And I'm trying to upload my videos, but it takes forever to upload my videos. So hopefully by tomorrow, they will all be on YouTube and will be all caught up again, okay? So, 4.5b, what was the last thing that we wrote down? Rationalize the denominator? Yes? Okay, so before we wrote rationalize the denominator, we wrote it is not proper to have a radical in the denominator. Do you agree? Okay, and then the next thing we wrote was rationalize the denominator. Okay, rationalize the denominator. So, what does it mean to rationalize the denominator? Did we write that down? No? Okay.
Eliminate the radical from the denominator.
Yeah, I thought we did. Eliminate the radical in the denominator. Okay, eliminate the radical in the denominator. So here's the deal, guys. You can't have a radical in the denominator. If any of your answers have a radical in the denominator, I will mark them wrong. I will not give you partial credit. If it took you 20 steps to get that answer and it's actually correct, but it's not rationalized, I will just mark it wrong. Okay? So don't have an answer that has a radical in the denominator. All right, so let's start off working some problems, and we're going to talk about some things. So example 2a, the square root of 5 halves. All right, so here's what I always say. I say if you have a fraction under a square root symbol, if you can reduce the fraction, you should leave them under the same square root symbol. If you can't reduce the fraction, then you should separate them. Can you reduce 5 halves? No, so we're going to separate it and write it as the square root of 5 over the square root of 2. Are you with me? Yes? Okay, so this is the correct answer. It's not in proper form because it has a radical in the denominator. All right, so does anybody know how I can get rid of that square root of 2? Okay, you can't square it because if you square it, you'll change the value of it. Okay, like if I took 3 and I squared it, would that change the value of 3? Yes, because what would it be then? 9. And is 3 equal to 9? No, so I can't square it. I can't change the value of it. What if I did this? What if I multiplied by the square root of 2? Would that get rid of the radical in the bottom? What is the square root of 2 times the square root of 2? 2. It's the square root of 4, which is 2. But we say it's 2. What's the square root of 7 times the square root of 7? 7. What's the square root of 13 times the square root of 13? 13. Yeah. So you're just going to multiply by the square root. Now, what's the rule?
You have top times top. You have to do the same thing to the top.
That's exactly right. Whatever you do to the bottom, you have to do to the top. Okay? So on the top, what's the square root of 5 times the square root of 2? Yeah, that's right. Square root of 10. Can I reduce the 2 and the 10? Why? Yeah. He's inside the house and he's outside the house, and they can't play together. Okay, so that's my answer right there. All right, so does anybody know, so y'all look, this is all you're doing. Whatever this is the square root of, you got to get rid of that square root, so you just multiply by it. Okay? Now, does anybody know why I multiply the top by the square root of 2 also? Okay, so all day, that's what the kids have said, because the rule is whatever you do to the bottom, you have to do to the top. I'm going to tell you why that's the rule, and if you don't understand it, don't worry about it. Just know you got to follow the rules. But here's what it is. Y'all, what's the square root of 2 over the square root of 2? 1. So if you multiply a number by 1, are you changing its value? No. So see, that's why I have to multiply it by the square root of 2 over the square root of 2, because then I multiply it by 1. That doesn't change the value of this fraction, it only changed the way I'm expressing it. Okay? All right, so let's try another one. Are you ready? This one's yours. The square root of 9/5. The square root of 9/5. Remember what I said. If you can reduce the fraction, you should leave it together. If you can't reduce the fraction, then you should take it apart. Okay, should I leave it together?
No.
No, you can't reduce 9/5, so let's separate it. The square root of 9 over the square root of 5. What is the square root of 9? 3. Can't take the square root of 5, so I'll leave it as the square root of 5. So this is my answer. Is it in proper form? No, it has a radical in the denominator. How do I get rid, y'all listen to me. You have to rationalize this. That's what it's called. You have to get rid of the radical in the denominator. So what am I going to multiply it by?
The square root of 5.
Yeah, the square root of 5. So you multiply the top by the square root of 5. That way we multiply by 1. On the bottom, what's the square root of 5 times square root of 5?
5.
On the top, what do you get?
3.
Yeah, 3 square root of 5. 3 square roots of 5. Hey, can I reduce these 5s?
No.
No. What's going to happen on the test? What's your brain going to scream at you? He's going to say, hey, reduce those. Reduce those. Don't listen to that, okay? Don't listen to that. What about this guy right here? Can you do this one?
Yes, you can make it 5.
Oh! Presley says, hey man, that reduces. What is 10 over 2?
5.
Is that as good as it gets?
Yes.
Yep, that's it. Okay, so do you see what I'm saying about reducing? It might not reduce down to an integer, but you might reduce the fraction. Okay, reduce it by a 2 or a 4 or whatever. All right, so here's my next one. This one's going to be a little bit harder. 3 over 7 plus the square root of 2. Okay, I'm rationalizing it. That means I'm getting rid of the radical in the denominator. What do you think I'm going to do?
Multiply by the square root of 2.
Multiply by this. Don't write that down. I'm going to write it down with a pencil so that I can erase it because obviously it's not right. Okay? So, but that is the common thing to say. Multiply by the square root of 2. When you multiply by the square root of 2, do you have to distribute?
Yeah.
And what will you get here?
Square root of 7 with the square root of 2.
7 square root of 2. Y'all listen to me. He's not inside the house. He can't play with that 2. Okay? He's playing with this 1 that's outside the house. So 7 times 1 is 7. So it's 7 square root of 2. Did you get rid of the radicals in the bottom? Nope. You made another one. All right? So that's obviously not what we're going to do. Okay, so I'm going to tell you what you need to do. You need to multiply by this guy's conjugate. You need to multiply by this guy's conjugate. What is the conjugate of 7 plus the square root of 2?
7
Very good. Now listen, watch what happens up here. Obviously, we're going to multiply the top by it also. Okay? Now watch what happens. When we multiply, y'all remember how we multiplied conjugates? Like x plus 3 times x minus 3. What happens to the inners and the outers? And they do what? They cancel each other out. A plus 3x and a minus 3x. They go away. And what do you end up with? The difference of two perfect squares. Square the first. Minus, square the last. Same thing down here, guys. Square the first. What do you get? 49. Minus, square the last.
2.
2. The square root of 2 squared is 2. That square and that square root just eliminate each other, and you got 2. What's 49 minus 2?
47.
47. So that is my denominator. Do I have a radical in it? No. All right? Let's distribute, and then I'll go back and cover that again. All right, so distribute here. What do I get? What's 3 times 7? 3 times negative square root of 2. Negative 7 square root of 2. Who am I looking at? Who am I looking at to see if this fraction reduces?
Wait,
Why is it negative?
yeah, why is it negative 7?
Oh, I don't know why it is, because I don't know. Sorry, thank y'all for saying something though.
Yeah, it was 3.
It is 3,
I
you're
think
right.
you were like, wait,
Negative-
Sorry.
Yeah,
So negative 3 square root of 2. Yeah, sorry about that. All right, so tell me what I'm looking at now to be reducing this fraction. What numbers?
21, 45.
And 3. Yeah. Y'all, you have to look at all 3 of these numbers. 21, 3, and 47. They're all outside the house. They can all play together. Y'all listen to me. If you can't take it out of every one of those, all 3 of them, you don't take it out of anybody's. Okay? We'll come back and talk about that. All right, so let's go back here and let's talk about these conjugate things. All right? So do you agree if I fold this out? What's first times first? What's 7 times 7? 49. Do you agree that the inners would be 7 square root of 2 and the outers would be negative 7 square root of 2?
Yes.
That goes away. And then the last times the last would be negative square root of 2 times square root of 2, which is 2. Right? Okay, so I can, when I'm multiplying conjugates, square the first minus square the last. Let's see how good you are. How long should that take us to do that? 5 seconds? I like that. Okay, so let's try it. We're going to do about 1, 2, 3, 4 of them, okay? So 2 plus the square root of 3 times 2 minus the square root of 3. All we want to do is get this so this is not a problem to us. We're part of working a problem, but we can do it really quickly. What'd y'all get for your answer?
1.
Very good. So you're going to square the first, 4, always minus because you got unlike signs right here, and square the last. All it's going to do is remove the radical, guys. 3. 4 minus 3 is 1. Anybody got a question? Okay, let's try another one. You do this one. 7 plus the square root of 6 times 7 minus the square root of 6. What'd y'all get?
43.
Very good. Square the first and what do you get?
49.
Minus, square the second.
6.
49 minus 6,
43.
43. Here's your next one. 5 minus the square root of 2 times 5 plus the square root of 2. Okay, you got it? What'd y'all get?
23.
Very good. Square the first is 25, minus square the last is 2, and that's 23. Okay, anybody need any more? All right, so we're gonna do one more. I'm gonna make it a little more difficult just to make sure you understand. So this one's gonna be a little bit different, a little bit harder, but I'm gonna tell you what you need to know, okay? So 6 plus 2 square root of 3 times 6 minus 2 square root of 3. So remember when you square something, you square everything. That's what you need to know. When you square something, you square everything. All right, what'd y'all get?
24.
Very good. So square the first, 36, minus. When you square this last, everything squares. What is 2 squared?
4.
4. What operation are you doing between this 2 and this radical?
Multiple.
Then that's what you're doing. And what is the square root of 3 squared?
3.
And 4 times 3 is 12, and 36 minus 12 is 24. All right, anybody got a question? Okay, so let's go back over here. I want to point out a couple of other things, okay? Here's the first one. I'm just going to make some answers up and ask you some questions about it. What if you got this as your answer? 12 minus 3 square root of 5 over 6. Tell me what you would need to do.
Reduce by
Yeah. Who reduces?
3.
Yeah, 3 goes into 12 and 3 and 6. I'm only looking at the guys outside, all right? So 3 goes into here 1 time, 3 goes into here 4 times, and 3 goes into here 2 times. So my answer is 4 minus, you can write the 1 or you don't have to, it doesn't matter, over 2. Okay? What about this guy right here?
He's fine.
He's fine. Now listen to me. That right there, that's going to scream at you in a test, and you're going to want to reduce that 4 and that 2. It does not work. That is my answer. Okay? What about this guy? Does he
by
reduce?
2.
Yes.
Okay, you reduce him and tell me what you get for your answer. Okay, y'all got it?
Mm-hmm.
Okay, so what goes into 2 and 8 and 4?
2.
2. So 2 goes into here how many times?
4.
2 goes into here how many times?
2.
So does this guy just go away?
No, he becomes
He becomes a what?
1.
Very good. So that's the careless mistake, is some kids will just knock him out, but you can't knock him out. He goes in there 1 time, so be careful about that. And he becomes 1 minus 4 square root of 3 over 2. Okay? Good job. All right, here's the last one that we're going to do like this. D 2 plus the square root of 5 over 4 minus the square root of 3. Okay? I'm going to let you work it really quick. I need you to rationalize it.
It's gonna be on the test book.
No. It's not. What's going to be on the test tomorrow?
Factoring.
Factoring and multiplying binomials. You can't do that. You can't do that. Did you take that out of everybody? No, that's it. What about these guys over here? You cheated. You can't do that. I took it out of this one, this one, this one. There's 3 terms. I took it out of everybody. Did you take that out of everybody? There's 3 terms. 1, 2, 3. There's 1, 2, 3, 4 terms. Did you take that too out of everybody? No, you can only do it if everybody. I could do it if it looks like this. You gotta take it out, you gotta have something out of these guys. I could do it here. Okay, but you can't cheat those guys and say, no, I'm not taking it. Okay? All right, what do you multiply by?
4 minus square root of 3.
Okay. For what?
Plus.
Conjugate. 4 plus. Hey guys, look, can you reduce this 2 and this 4?
That's what I did.
Y'all listen to me. You cannot reduce the 2 and the 4. How many terms are up top? 2. How many terms are up bottom? 2. So there's 4 terms and you said, hey, I'm only gonna reduce 2 of you. Is that fair? No. If you can't reduce everybody, you can't reduce anybody. Okay? So you can't do that. All right? You can't do that. Do y'all understand why? Say no if you don't so I can show you.
You can only reduce it like in the answers.
Okay, so what? No, thank you. Thank you for saying that because there's somebody sitting at home that's going, I don't know why, but I can't ask you a question, lady. All right, so I'm gonna go back up here and I'm gonna show you. If it looked like this, 2 plus 4 square root of 5 over 4 minus 8 square root of 3. Now do you understand how I can take a 2 out of everybody?
Yeah.
Now that's when you can reduce. I can make this a 1 and this a 2 and this a 2.
So there has to be a number in front of all of
Yes.
the things.
Because you have to take something out of this guy, this guy, this guy, and this guy.
Okay, I get it.
Okay? So this would reduce down to 1 plus 2 square root of 5 over 2 minus 4 square root of 3. Okay? But this guy will not reduce. You cannot do that. All right? Okay, so what am I going to multiply? 5. What'd y'all say?
4 plus square root.
4 plus the square root of 3? I'm glad I saw that, because I'll bet you that all day that the kids have been doing it, but nobody's sent anything to me. Okay, so on the bottom, can we get the answer really fast? What is it? 16 minus 3. What is 16 minus 3?
13.
13. Okay, on the top, people, you got to foil it. Okay, F-O-I-L. So, first times first. What's 4 times 2? 8. The outers, watch how I'm going to write it. The outers give you 2 square roots of 3, and the inners give you plus 4 square root of 5. Can I collect those?
No.
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 You could multiply them, but you can't add and subtract them. Okay? They have to be the same radical and the same radicand. And here's what I'm talking about. We're going to do it later on, okay? But what if I had 2 square root of 3 and I added it to 4 square root of 3? That's saying, well, if you have 2 square roots of 3 and I give you 4 more square roots of 3, what do you have? 6 square roots of 3. So do you see how it's kind of treated like a variable? So you can't add these two things right here. So we just write them down. Plus 2 square root of 3 plus 4 square root of 5. Plus, last times last is what? Square root of 15. Can I simplify any of those radicals? No. 3, 5, and 15? Nope. Can I collect any of that?
No.
No. That's my answer. Can I reduce anything?
No.
Nope. I see an 8 and a 2 and a 4, but he's got a 1, so I'm out. And he's a 13. Anybody got a question? Okay, so now I'm going to show you how to work some problems on your worksheet. Okay? Obviously that was some of the stuff on your worksheet, but there are some problems like this on your worksheet. I got 3 more examples, and that's it. Example 3, 3x squared plus 5 equals 41. Okay, normally if we're solving a quadratic, what's a quadratic? What's it got that makes it a quadratic? An x squared. Okay? I would say, hey, you need to set it equal to 0 and factor and solve. But there's an easier way to do this one. This one, I'm going to subtract 5 from both sides. Tell me why I'm doing this one differently.
Because your great square is going to equal that, and you can just
That's right, because what does he not have?
another x.
An x, that's exactly right. He doesn't have what's called a linear term, the x term. He doesn't have a plain old x anywhere. So I just got an x squared and some plain numbers, some constants. So I'm going to say 3x squared is equal to, what's 41 minus 5?
33.
Now what am I going to do?
Take the square root of it.
Before I take the square root, I need to get that squared all by itself.
Divide that over.
There you go, divide by 3. Now it's by itself, and x squared is equal to 36 divided by 3 is 12. Now what am I going to do?
Now you're gonna square root it.
Yeah, now I'm going to square root it. Oh, let's see who remembers. The square, y'all look, a square and a power of 2, a root and a power of 2, they cancel each other out. So you're left with x is equal to, what should be the very first thing you write down here. Not one person's gotten this right today.
Wait.
Makes me
this-
sad.
this-
3 and 4.
No.
Aren't you gonna simplify it?
Oh, okay, so remember we talked about that. Whenever you're solving an equation and you take a square root, you have to put a plus or minus. That takes care of those 2 answers, right? Because remember Freddie Goss, he said whatever the highest exponent is, that's how many solutions I can have. All right? So is there a perfect square that's a factor of 12?
No.
What?
4.
4. All right. 4 times 3. What's the square root of 4? 2. Since I took its square root, it goes outside, and the 3 stays underneath. Okay? All right, so I'm going to show you, here's a picture of your worksheet. All right? This is the front of it. Okay? Remember, did we do something like this? Where you just cross-canceled and did all that stuff?
We did one.
Okay? All you gotta do is cross-cancel and everything. Like I'd say 9 goes into 18 2 times, 7 goes into 35 5 times, 2 goes into 72 36 times. 36 and 44 have a common factor. Okay, so you could do stuff like that. All right, now look at the back. Okay, look at the back. Do you see this problem, this problem, this problem, this problem, and this one? Are those just like the ones we just worked? Okay, did I factor anything? People, look at that. Did I factor anything? No. Don't be factoring those, okay? Don't be factoring them. First of all, he's not gonna factor, okay? So, just do them like this. All right, so look at these other ones. Do you see 18, 19, 20, 21, 22, 23, 24, all of those, okay? So, let's do one like that. Example 4. Mine's gonna look like this. 1/7 times x minus 2 quantity squared equals 6. Okay, so here's what I'm gonna do. I'm gonna treat this quantity the same way I treated that x squared. I'm gonna see if I can get this quantity squared by itself so I can take its square root. So what do I need to get rid of? The 1/7. What would I do to get rid of the 1/7?
You do the reciprocal.
Multiply by the reciprocal. What's the reciprocal of 1/7?
7.
All right, so multiply this guy by 7 and that guy by 7. These are gone, and I'm left with x minus 2 quantity squared is equal to 42. Okay, so is the quantity squared by itself? So can I take its square root now? All right, so I'll take square root and square root. These cancel each other out. What am I left with?
X minus 2.
X minus 2. What is the first thing that you should write down?
Plus and minus.
Plus or minus. Very good. Okay, is there a perfect square that's a factor of 42?
No.
No. So we'll just write the square root of 42. Okay? Now all I gotta do is solve for x. So this -2, I need to bring it over here, and what will it become? A positive 2. You could say I'm gonna add 2 to both sides, but listen to me. That 2 goes in the front. It does not go in the back. Your answer is 2 plus or minus the square root of 42. 2 plus or minus the square root of 42. Okay, so I'm gonna show you something really quick, and then I got one more problem and I'll be done. Maybe you'll have about 7 minutes or something to work on your worksheet or ask questions. All right. So do you agree that if I pulled this 6 over here and this was equal to 0, that I could graph it? I could place a y in place of that 0? Do you all agree?
Yeah.
Yeah? Okay, so that's what I'm going to do. Y is equal to, and I'm going to say 1/7. I'm going to do it as a fraction, but only because last period the kids did not like it because I didn't use the fraction button. X minus 2 quantity squared minus 6. Okay, so here he is right here. I'm going to go zoom 6, which is standard graph. Well, that's pretty much what I was expecting. It's a parabola, and he opens up because of this positive 1/7. He's pretty wide because of that 1/7. Okay, these 2 points right here, these 2 x-intercepts, anybody know what they are?
It's like 6.
They're those 2 numbers right there.
Plus or minus.
2 plus the square root of 42 and 2 minus the square root of 42. These are my solutions, my x-intercepts, my zeros, my answers, my roots. They're all the same thing. So I'm just going to show you one for the sake of time, all right? So I'm going to go second and calculate. What am I calculating? a 0, so I'll choose number 2. He's gonna ask for a left bound and a right bound. There's 2 of them, and he's like, hey lady, which one do you want? Give me some boundaries here, okay? If you read this curve from left to right, left bound, I'm gonna do this one right here, of this one is below it. Do you agree with that? Yes? Okay, so I'm gonna go to the right until I get just kind of below it a little bit. You don't have to get really close, it doesn't matter. All right, so there's my left bound. Now he wants a right bound. He wants to say between what 2 places. So a right of this 0 would be above it. So now I'm gonna move my little arrow, my little spider, up here to above it. I don't wanna guess, so I'll press enter. So there is the number that it tells me. It says 4807407. Do you agree? Okay, so watch what I'm fixing to do. Second and quit. What is 2 plus the square root of 42? That number right there. Okay? Pretty cool, isn't it? X-intercepts, solutions, zeros, answers, and roots. All right, one more question. This last question, this is an equation that's going to come up quite a bit through the rest of this year. It looks like this. H is equal to negative 16t squared plus h sub 0. Okay? So anything sub 0 is when time is 0. So this h and this h, they're the same thing. They mean height. But this is when time is 0. This is initially, before the problem began, this is my height. Okay? So this is my initial height. Anything sub-0 is initial, in the beginning. This right here, he's my ending height. Okay, this negative 16 has to do with gravity, and that's physics. I'm not a physics teacher, so I'm not going to really talk about it. I gave you the formula, so that's what it has to do with. All right, so do y'all remember, have y'all done an egg drop before in science class, where you stood up here at the top of the bleachers, right, and you dropped an egg down to the ground? Do you agree? So we had an egg drop, trying to keep your egg from breaking, of 50, dropped from a height of 50 feet. Okay? How long does it take it to hit the ground? Okay, so obviously that's my time in my equation, all right? What's my initial height? 50, because that's how high you were up there, okay? So that's negative 16t squared plus 50. What's my ending height? 0, because it would be on the ground. Can I solve this the way we did the problem before this?
Yeah.
Tell me what to do.
Minus 50.
Minus 50, perfect. So now I got 50 is equal to negative 16t squared. Now what am I going to do?
Divide by 16.
Divided by negative 16.
Minus
Oh, sorry, I was like, something's wrong. Divide by negative 16, and t squared is equal to positive 50 over 16. I could reduce it, okay, but I'm not going to because I'm going to use a calculator anyway. So square root both sides, and t is equal to plus or minus. I'm just going to pop it in my calculator. I'm going to say the square root of 50 divided by 16. I'm going to call it 1.8. Okay? 1.8. Now, tell me, it's 1.8 seconds, guys. All right? Tell me about the negative 1.8 seconds.
Not right.
Yeah. You can just throw that one out. He doesn't make any sense. Can you go back in time?
No.
No. Once you've said something not nice about someone, you can say, I'm sorry, but it's still out there, you can't take it back. So the negative in this case will be thrown out, And my answer would be it takes 1.8 seconds for the egg to hit the ground. All right, so you got about 9 minutes, so get your worksheet out. It is due tomorrow. If you have some questions, I will turn the light on and be up at my desk.